Okay, so let's get real for a second. Your AI models are probably scattered everywhere, right? Some on AWS, some on Azure, maybe a few over on Google Cloud. Now, this isn't just a messy technical puzzle, it's kind of like a ticking time bomb for compliance and reliability. In this explainer, we are going to defuse it. We're going to build a control tower for your AI, no matter where it lives. Let's jump in. So here's our game plan. We'll start by unpacking that whole multi-cloud puzzle. Then, we'll build a solution from the ground up using 4 key pillars. We'll see how it all works by following a financial models journey. Check out the automated watchtower that protects it, and finally, really nail down how this whole framework can flip a business from taking huge risks to being incredibly reliable.
All right, let's dive right into the heart of the problem, this challenge of distributed intelligence. So, picture this. Your data science team absolutely loves the tools on Google Cloud. Your main apps? They all run on Azure. Oh, and that company you just acquired? Yeah, their entire workload lives on AWS. So your AI is literally all over the map. And that forces a really big, kind of scary question. Who's actually in control here? When something inevitably goes wrong, who gets that call?
You know, we can actually make this whole complex mess a lot simpler with a really good analogy. I want you to think of AI governance as the air traffic control system for your models. Each cloud is a different airport, and every single model is a plane. Now, without that central control tower, you just have chaos. You've got planes taking off without clearance, flying in unapproved airspace. It is a total recipe for disaster. So how do we build that control tower? Well, the blueprint for it rests on 4 fundamental pillars. Seriously, these are the non-negotiables, the absolute foundations you need for managing AI at scale, especially when you're juggling different cloud environments.
First up is lineage. This is basically the model's birth certificate and its entire life story all rolled into one. It's this perfect, unbroken, auditable chain that tells you exactly what data was used for training, which version of the code was run, and precisely which version is live in production right now. And for anyone in a regulated industry, this isn't just a nice to have, it's what the auditors demand.
Now that crystal clear lineage feeds directly into our next pillar, approvals. Think of these as the critical checkpoints, the formal gates, like bouncers of the club, in your deployment pipeline. Before any model gets deployed, it has to be signed off. This could be an automated check for security holes, a human review of its business logic, or a final thumbs up from a stakeholder. It's all about making sure no rogue models ever make it into the wild.
Okay, so a model gets approved and deployed. Our job isn't over, not by a long shot. We need eyes on it all the time, and that's monitoring. This system is constantly watching a model's performance in real time. Is its accuracy starting to drop? Has the real-world data changed so much that the model's predictions are becoming, well, kind of useless? That's what we call drift. Basically, is the plane still flying safely on its intended course?
And if monitoring does spot a problem, well, that leads us straight to our final pillar, rollback. This is your emergency safety net, your eject button. If monitoring sees a critical issue, like the model's accuracy suddenly just falls off a cliff, you can't afford to be scrambling around manually. An automated rollback plan instantly swaps out that faulty model with the last known stable version. It is the abort takeoff button that prevents a catastrophe. All right, theory is great, but let's put these 4 pillars into practice. Let's imagine we're multi-cloud architects at a big, heavily regulated company, and let's follow one of our models on its journey to production.
So here's the scenario. We're working for a major bank, and our mission is to deploy a brand new credit risk model. And believe me, the stakes could not be higher. One little mistake could lead to millions in losses, or even worse, massive regulatory fines. Compliance and reliability, they are absolutely 100% non-negotiable.
So this is our MLOps pipeline, and yeah, it probably looks a lot like a standard software pipeline, right? You're validating code, you're running automated tests, but look really closely at step 3. We have plugged in a dedicated governance approval gate. This is where those pillars we talked about really come to life.
So long before this model gets anywhere near a real customer, it slams into this gate. The system automatically pulls up the model's entire lineage, checking if it was trained on approved data, making sure the code passes all the security scans. Then, after all those automated checks, it might go to a human compliance officer for that final sign-off. That gate only swings open when every single box is checked.
Okay, our model made it. It passed the gate, and it's now live, making real credit decisions. But we're not done. In fact, the most important work is just beginning. Now the automated watchtower takes over.
And this watchtower is constantly scanning for all sorts of critical issues. I mean, sure, it's watching for performance degradation, that's obvious, but it's also looking for those subtle things, like data drift. When the economy changes and the data the model was trained on just isn't relevant anymore. It's also scanning for prediction bias, making sure the model is fair, and checking for things like security vulnerabilities or sudden latency spikes.
And here's the kicker. If the monitoring system sees that one of these metrics has crossed a critical line, it doesn't just send an alert and hope for the best. Nope. It triggers an immediate automated rollback. The problematic model is instantly pulled from service and replaced with the last stable version. No frantic 3 a.m. phone calls, no manual intervention needed. The system just protects itself.
So let's zoom out and ask the big "so what" question. Why do we go through all this trouble? Let's take a look at the real, tangible business impact of putting a strong governance framework like this in place.
I mean, the difference is just night and day. Without governance, you're flying blind with huge compliance blind spots. With governance, you have a fully auditable lineage ready for any regulator. You go from doing these stressful, risky manual rollbacks to having automated safety nets. You replace inconsistent, unpredictable performance with reliable, monitored operations. And you transform what was a slow, chaotic deployment process into a fast, secure, and automated pipeline. It changes everything.
So when you boil it all down, here's the crucial point. Proper governance transforms your entire AI operation. It stops being this high-risk experimental gamble, and it becomes what it was always supposed to be, a reliable, scalable, and totally compliant engine for driving real business value.
And that leaves us with one last and maybe most important question to think about. You might have a system that works for the models you have today. That's great. But with how fast AI is changing, with new regulations coming down the pike and totally new types of models on the horizon, is your governance framework really agile enough for tomorrow?